Hey, what's up, everybody? This is Joey, the resident math guy at Thinque Prep, and today we're going over the free response question number 4 from the AP Calculus AB and BC exam administered in the year 2019. So here in question 4, we're given a cylindrical barrel with diameter of 2 feet, and then it says the water drains out through a valve not shown at the bottom of the barrel. The rate of change of height of the water in the barrel with respect to time t is modeled by this differential equation right here, where h is measured in feet and t is measured in seconds. And then they're lovely enough to give you the volume of a cylinder right here. Part A asks us to find the rate of change of the volume of water in the barrel with respect to time. That's actually dV dt when the water is 4 feet. So we know that h is just equal to 4. So in order to do this problem, we're going to start off with this volume formula that they give us. So we know that volume is equal to pi r squared h. And in order for us to do this problem, we need to take the derivative of both sides with respect to t. Now the left side is super easy to take that derivative. The derivative of v is just dv dt. The right side is a little bit more tricky. So we have this pi as a constant, so we can factor that out in front. But if you notice, r squared times h is actually a product with two variables. So when we have a product with two variables, then we need to do the product rule. So the product rule goes, we take the first value, and then we times it by the derivative of the second. The derivative of the second is dh dt. And then we have to plus it to the second times the derivative of the first. The derivative of the first is 2r dr dt. Remember to use the chain rule here. Now if we want to go ahead and simplify this, let's look at this dr dt. dr dt is the rate of change of the radius of the cylinder. And notice that this is a cylindrical barrel. That means the radius is not going to get any bigger or any smaller. So we can think of the radius as just equal to 0. That means this entire term here is eliminated. So then dV dt can be written as a simplified form as pi r squared dh dt. And then from here, we can go ahead and plug in the values that they give us in the function. If we know that the diameter is 2 feet, then we know the radius is equal to 1 foot because the radius is half the diameter. So it's pi times 1 squared. And then they give us the function for dh dt. So we can plug that in as negative 1 over 10. Square root of h, the question gives us that h is equal to 4. And then if we were to simplify that, it becomes negative 1 over 5 times pi. If we look at the units, I circled them earlier. It's in feet and it's in seconds. Since this is a volume, we know that the units will be cubic feet per second. Now there's a little bit of a more simple way of doing this if you can think about it conceptually. So if we know that the volume is pi r squared h, and if we were able to see earlier on that the radius is constant, we could have treated this whole thing as a constant. So we could have written this as pi r squared, factored that out, and then just taken the derivative of h with respect to t times dh dt. This is a little bit more of a conceptual way of doing the question, but as you can see, this part matches this part, and it would have led you to the same answer either way. Part B asks, when the height of the water is 3 feet, is the rate of change of the height of water with respect to time increasing or decreasing? Explain your reasoning. Now, upon first reading of the question, it sounds like all you need to do is plug in this 3 into here and just figure out if it's positive or negative. But reread the question a little bit more carefully. It says, is the rate of change increasing or decreasing? In order to determine if the rate itself is increasing or decreasing, then we need to take this and take the derivative of that. So we're going to start off by writing out the rate of change of height with respect to time. It's just negative 1 over 10 square root of h. And then just to be a little bit redundant, I'm going to write out exactly what I'm doing using this notation. That way I can see what I'm doing to both sides. So when I take the derivative of this left side, I'll get d squared h over dt squared. And on the right-hand side, I'll take the derivative of this negative 1/10 is a constant. When I take the derivative of h, remember that h square root of h is the same as h to the 1/2 power. So then I can bring down the 1/2 using power rule. And then when I bring down the 1/2, I have to subtract 1 from the power. 1/2 minus 1 is negative 1/2. And then here's the tricky part. Because I'm not taking the derivative with respect to h, because I'm taking it with respect to a different letter, I need to multiply it by dh dt. That's the chain rule for you. So this is an easy spot for people to miss out on a point. And then they give us dh dt, so we can plug this into here. So let's simplify a little bit more. Negative 1/10 times negative 1/2 is negative 120. This can be written as 1 over square root of h. And then dh dt is negative 1 over 10 times rad h. And lo and behold, these square roots cancel. These two minus signs cancel out. And then we get the answer is always positive 1 over 200. So then explain our reasoning. So we can say, because d squared h over dt squared is greater than 0 for all h, dh dt is increasing when h is 3 feet. And there you go. In part C, we're told that when t is equal to 0 seconds, the height of the water is 5 feet. Use separation of variables to find an expression for h in terms of t. So this is our differential equation that we're going to start with. dh dt is equal to negative 1 over 10 square root of h. And so what we're going to do is we're going to divide both sides by root h to get it over to the left-hand side. So this is 1 over root h. And then we're going to multiply both sides by dt. So then we get 1 over root h dh is equal to 1/10 dt. And in doing so, by separating these variables, then we can take the integral of both sides. Now remember that 1 over root h is the same as h to the negative 1/2 power. So then when we take the integral of both sides, this becomes h to the 1/2 power times 2 over 1. And then on the right-hand side, we're taking the integral with respect to t, so this is just negative 1 over 10 t. Now don't forget, since these are indefinite integrals, I have to have a plus c somewhere, so I'm going to put it over here. If you do not put this, they're going to dock you many, many, many points. Okay, so now let's simplify this so it's a little bit easier to look at. This is 2 root h is equal to negative 1/10 t plus c. How the heck do we find the value of c? Well, we have this point here. When t is equal to 0, h is equal to 5. So let's plug that in. 2 root 5 is equal to negative 1/10 times 0 is 0. So this is my c value right there. And then now I can just write out my final equation. It's 2 root h is equal to negative 1/10 t plus 2 root 5. Let's divide everything by 2. Root h is equal to negative 1 over 20t plus root 5. And then we can go ahead and square both sides. And that's your answer for part C. Thank you so much for watching this video. If you have any questions, feel free to leave a comment below. Otherwise, if you found this video helpful, give us a thumbs up or subscribe to our channel.